Hello aspirants, today we are going to discuss the formula of magnetism and matter. We can see that first we take the pen. Okay. We can say that magnetic field, magnetic field is also known as magnetic induction, magnetic induction. We can also call it as the magnetic flux density. Magnetic flux density. If in question, if asked anything, it talks about magnetic field, it talks about magnetic induction, it talks about magnetic flux density, all are the same. First we find the magnetic field due to small a element vector. Magnetic field found for a small element vector. This formula is dB is equal to mu naught I upon 4 pi d ideal sine theta upon r square. This is the scalar form. This form is the dB is equal to mu naught I 4 pi d ideal sine theta. This is the scalar form. If you want to write the vector form, then mu naught I upon 4 pi I cross dl upon r cube, dl cross r. This is the vector form. Okay. One important point is that जो dB is perpendicular to IDL and dB is perpendicular to R, always. This result is always valid. Now, next slide. Second formula, if point P is if point P is on wire, if point P is in on wire or at the axis of where then magnetic field will be 0. If point P is on wire or the axis of wire, then magnetic field will be 0. What it says that this is the wire, this is the current falling from wire. If magnetic field asks about this point, then magnetic field is 0. If this is the x-axis, this is the y-axis. If the current flow, this is the wire, current flowing from this way, and there is one wire, this current flow is magnetic pole, suppose this current is I1, this current is I2. The magnetic field due to I2, magnetic field due to I2 is 0, and magnetic field this portion and this portion comes at the axis. This wire, if we extend this wire pass through the axis. So magnetic field due to this part and this part tends to be 0. This point explains these things. Now magnetic field due to infinite wire, suppose this is the wire, infinite tends to infinity. Here we take the point P. We ask magnetic field at point P. Magnetic field at point P due to infinite wire. So for this kind of question we have to find magnetic field at point P. So we have to join perpendicular line which joins the P, and we have to join the end of wire and the point P where the magnetic field we have to find. We have to join the ends of wire from point P. The both ends are at infinity, so that point P joins the wire at infinite. So it will take to infinite, means point P, if we extend this line, it will join at infinity. So you know the general form of the magnetic, mu naught I upon 4 pi d sin theta 1 plus sin theta 2, b is equal to mu naught I upon 4 pi d sin theta. This theta infinity, this theta joins at this line joins at infinity, so theta is 90 degree. This line also joins at infinity, so theta is 90 degree. So sin 90 plus sin theta 2 is also 90 degree, so sin 90 plus sin. This mu naught I upon 4 pi d sin 91 sin 91. If we extend this further, that we will get the result mu naught I upon 4 pi d into 2 से 2 cancel, mu naught I upon 2 pi d. We can say that magnetic field due to infinite wire at point P is equal to mu naught I upon 2 pi d. This is the result we have to remember. Now we can check magnetic field due to semi-infinite long wire. Now magnetic field due to semi-infinite long wire. Semi-infinite means the one end of the wire is at infinity and the other end is at finite distance. Suppose this is the wire, this part is at the infinity, and we have a point P. This is the case 1. Here we can draw case 2. This end is at infinity and the point P lies directly at the base in front of the base of the other end, and the case 3 is that this is the wire, one ends at infinity and the other end, the point is below the base of the other end, that is point B is here. There are the three cases which are formed due to magnetic field due to semi-infinite long wire. Now we have to find the magnetic field for the first case. First, step 1. Here we can write the steps, that is, change the color. Steps. First steps. Joins both end of wire. Joins both end of wire to point P. The second step is draw perpendicular line joins point P to wire, and the third step is the take angle. Now can we check that now? First we select the end, this end joins point P here, other end to infinity, so it will join the second end at where, that is at infinity. Here we can join this and second will be infinity. Here we can perpendicular line, so we have to extend this line for perpendicular. We can extend this line and the perpendicular line here. This is the perpendicular. One end will be joins at infinity and the other will join like this. Okay. Now joins both ends of the wire at point P. Draw perpendicular line to join point P to the wire. Now that to take angle, here is the perpendicular line. This is the perpendicular line. First angle, this angle is the 90 degree. Second angle is this. Therefore, we know that general formula of magnetic field, mu naught I upon 4 pi d sin theta 1 plus sin theta 2. This is the general formula of magnetic field. Mu naught I upon 4 pi d sin theta 1. Theta 1 is the 90 degree. Theta 2 is the theta 2. We assume that any angle theta 2. The sin 90 degree plus sin theta 2. Mu naught I upon 4 pi d sin 91 plus sin theta 2. This is the formula. So final formula we can say that mu naught I upon 4 pi d 1 plus sin theta 2. And this is the formula. The second one, the theta 1. This is the 90 degree, or theta 2 is the 0. Theta 1 is the 90 degree and theta 2 is the 0 degree. Write the general formula mu naught I upon 4 pi d sin theta 1 plus sin theta 2. Magnetic field mu naught I upon 4 pi d sin 91 plus sin theta 2 0 sin 0 0, that is mu naught I upon 4 pi d. This is the word. Case third, this angle will take theta 1 and this will be 90 degree. Write the general formula mu naught I upon 4 pi d sin theta 1 plus sin theta 2. Mu naught I upon 4 pi d sin theta 1 91 plus sin, sorry, both are in same direction. See, here and here both are in same, then it will be minus, it will, here is the minus, here is the pen word 1 minus sin theta 2. This is the third case. So magnetic field we have find that मैग्नेटिक फील्ड एट द पॉइंट जो बेस पे रहेगा एकदम म्यू नॉट आई अपॉन 4 पाई डी, बीच में रहेगा उसका म्यू नॉट आई अपॉन 4 पाई डी इंटू 1 प्लस साइन थीटा. मैग्नेटिक फील्ड एट पॉइंट पी म्यू नॉट आई अपॉन 4 पाई डी 1 माइनस साइन थीटा. We have already found that magnetic field due to infinite long wire. Now the third case we are discussing the pages. Now to find the position of neutral point, how to find the position, how to find the position of neutral point. Suppose there is a magnetic field dot means the magnetic field is outside. This is the wire, this is the wire. Now you have to find the magnetic field at point P. Suppose this is the distance x meter, sorry, x centimeter. Assume this is the, suppose L centimeter length. Suppose this is the x centimeter. This portion will be x minus L centimeter. Now we write the magnetic field at point P. Due to this wire, suppose this wire is the A, this wire, magnetic field at point P due to wire A, mu naught I, this is the infinite wire, mu naught I upon 2 pi x plus mu naught I upon 2 pi x minus L. Suppose neutral point पर magnetic field 0, तो mu naught I upon 2 pi x is equal to mu naught I upon 2 pi x minus L is the negative. Mu naught I से mu naught I get cancelled, 2 pi से 2 pi x minus x plus L, 2x is equal to L, x is equal to L by 2. Magnetic field lies in between. If the same current flowing in the same direction, we have to find the magnetic field at मीड पॉइंट। अगर दो करंट एक ही डायरेक्शन में जा रहे हैं, चाहे अंदर की तरफ चाहे बाहर की तरफ, अगर मैग्नेटिक फील्ड निकालना है तो बीच में आएगा। जनरल फार्मूला फॉर दिस, general formula for this x is x square I star d upon I1 plus minus I2। x is the distance, I star जिस वायर से न्यूट्रल पॉइंट निकालना हो, सेम डायरेक्शन करंट न्यूट्रल पॉइंट बीच में, अपोजिट डायरेक्शन करंट न्यूट्रल पॉइंट आउटसाइड। ओके, कंफर्म। द नेक्स्ट, now to find magnetic field, to find magnetic field at center of a regular polygon। हमें फाइंड करना है मैग्नेटिक फील्ड सेंटर पे रेगुलर पॉलीगॉन। व्हाट डू यू मीन बाय रेगुलर पॉलीगॉन? दिस इज द स्क्वायर ए बी सी डी, रेगुलर पॉलीगॉन। यहाँ पर मैग्नेटिक सेंटर में फाइंड। दिस इज द ट्रायंगल, this is also the regular polygon, this is pentagon A B C D, regular magnetic field यहाँ फाइंड करना है। this is the hexagon A B C D E F, this is the octagon, मैग्नेटिक फील्ड यहाँ फाइंड करना है। तो for this all the figure, the magnetic field, this is the center, that is O. Magnetic field at point O, O is the center, is mu naught I upon pi A sin pi by n tan pi by n। A is the length of the side, we write that A is the length of side और n is the number of side। Magnetic field at point A is equal to mu naught I upon pi A sin pi by n upon, sorry, mu naught ni, mu naught multiply by n, mu naught ni upon pi A sin pi by n tan pi by n, where is the n is the number of side। Magnetic field due to circle, this is the circle, this is the current। Magnetic field at point O, mu naught I upon 2r। If this the half circle, the current I, point O, magnetic field at point mu naught I upon 4 pi r। If this is current I, magnetic field at point mu naught I upon 8r finding, mu naught I upon 2r, mu naught I upon 4r, mu naught I upon 8r for any angle, for any angle, magnetic field at point mu naught I alpha upon 4 pi r. Alpha is the angle here. Here the angle is 360 degree. Theta assume यहाँ theta is 180 degree. Here theta is 90 degree. If you put the values in third one, magnetic field mu naught I alpha upon 4 pi r. Mu naught I alpha 90 degree, that is pi by 2 upon 4 pi r. Pi to pi cancel. Mu naught I by 8 r. Third one, proof. For the second one, this also pi 2 pi, we get the same one. That will, it will conclude now. Okay.